Okay, we have a couple of different things we are going to look at in day 2 of section 5.2, which was our linear factors and zeros of polynomials. And before we get into like how is this new from what we were doing before, I am going to just start off by asking our question here. What are the zeros of our function f of x equals x to the 4th minus 2x to the 3rd minus 8x squared? What are their multiplicities? Whatever that means. We don't know what that word is yet. And then graph the function. All right, so we have this question, we're finding our zeros, and that process is the same as what we were doing the first day of section 5.2. To find our zeros, we need to factor. So looking at x to the 4th minus 2x to the 3rd minus 8x squared, I notice that all of these terms have an x squared in common. Okay, so I'll stick with my pink here. Factor out my x squared, and then I still get x squared, because x squared times x squared is x to the 4th. X squared times negative 2x gives me negative 2x cubed. And then x squared times negative 8 gives me negative 8x squared. And once I factor that x squared out, what numbers multiply to negative 8 and add to negative 2? We have negative 4 and positive 2. Bring that x squared down. So my zeros, when is x minus 4 equal to 0? When x is 4. Okay, when is x plus 2 equal to 0? Well, that's when x is negative 2. And when is x squared equal to 0? Well, if you square root both sides, we only get one solution at 0 here. So we have zeros at 4, negative 2, and 0. We found our zeros, but then we have the second part of our question. What are their multiplicities? What does that mean? All right, multiplicities. Multiplicity here really means how many times a factor appears. So looking at our zeros here, we had a 0 at 4. And if I look at that factor, the factor of x minus 4, which gave me a 0 at 4, this x minus 4, we only see x minus 4 once here, which means this 0 has a multiplicity of 1. My 0 at negative 2 came from the factor x plus 2, and again, that x plus 2 is only here once. Okay, I only see x plus 2 here once, so we also have a multiplicity of 1 here. If I look at the 0 though, the 0 at 0 came from our factor x squared. And because of the second power here, that means this factor appears twice, and I have a multiplicity of 2. Okay, multiplicity of 2 there. So why on earth is multiplicity important? Why can't we just keep going like we normally would? Well, multiplicity is important because multiplicity affects the shape near each zero. And remember, when we're talking about zeros, we're really meaning our x-intercepts. Okay, here's how our multiplicity affects our shape. If we have a multiplicity of 1, the function goes straight through the x-axis. So if you had a graph of a polynomial, and let's say I have a cubic function that has 3 x-intercepts, okay? Each of these, if this is what my function would look like, I know each x-intercept, each 0, has a multiplicity of 1 because that function goes straight through. It goes straight through, goes from one side of the x-axis to the other, one side to the other, one side to the other. Okay. If we have a multiplicity of 2, the function bounces off the x-axis like a quadratic, like a parabola. All right, so let's say here I have a polynomial function. Let's do a quartic function here that has 2 x-intercepts. Okay. If I look at my graph looked like this, I would know that each of these zeros has a multiplicity of 2. Because if you look at just this little tiny chunk here, that looks like a parabola. Okay, this looks like a quadratic. We hit the x-axis and we bounce off. And same thing here. This little chunk looks like a parabola. We hit the x-axis and then we bounce off. Okay, so we never actually cross the x-axis if you have a multiplicity of 2. And if we have a multiplicity of 3, the function levels off near the x-axis before crossing. Kind of like our function y equals x to the 3rd power. So I'll draw kind of a weird looking polynomial function here. If I had a polynomial that looked something like this, okay, looking at this graph, so this is a pretty crazy looking polynomial function. My x-intercept here would have a multiplicity of 3. If you notice how it levels off, it's pretty flat near the x-axis. Okay, but we still cross. Right here, this 0 would have a multiplicity of 2 because we bounce off the x-axis. Okay, we don't actually cross the x-axis here, but we bounce back the direction we came. And right here, this x-intercept would have a multiplicity of 1 because our graph goes straight through. Nothing weird happens here. Okay, so knowing all of this information about our function up here and how our multiplicities affect our graph. Okay, let's look back at what we know. We know we have zeros at 4, -2, and 0. Okay, and I'm going to copy some of this information down below here so we can actually go to get our graph. Before that, though, I'm just going to kind of like put this information in a box, because the idea of this multiplicities and how it affects our graph is really, really important. Okay, so again, we had that function y equals x squared times x minus 4 times x plus 2. We have zeros at 0, 4, and -2. So let's start to make our sketch. The rest of the sketching process is very similar to what we were doing before. We just have to deal with that idea of the multiplicities here, okay? But I know we have zeros at 0, at 4, and at -2. Don't forget that when we're making a sketch, we also want to include our y-intercept, and then we want to show our correct end behavior. So since our degree is even here, we had a degree of 4, that tells us that both of our ends are going to go up. And our y-intercept, don't forget to figure out our y-intercept. We plug 0 in for our x value. That would be 0 squared times 0 minus 4 times 0 plus 2. Well, that's all going to be 0. Okay, so my y-intercept is really right here. Okay, so let's fill in the information we know. We know the ends are going to go up. The ends go up. Okay, now to fill in the rest of our graph, we really have to go 0 by 0. At this 0 at -2 here, -2 we set up above that x-intercept had a multiplicity of 1. So our graph goes straight through. And at some point, we're going to turn around, hit our x-intercept here, our x-intercept at 0, which we said has a multiplicity of 2. Now that multiplicity of 2 tells us that our function bounces off the x-axis like a quadratic. So right here, we hit our x-intercept, but we bounce off. We don't actually cross. And at some point, we turn around. Again, we don't really know where that is. We turn around, though, before we head back to our 0 that we had at 4. And that 0 at 4 had a multiplicity of 1. So we go straight through the x-axis.